So we're going to go ahead and start naming compounds. And so I want you guys to go back to your naming compounds flowchart. You can find this in Google Classroom. So we've gone ahead and talked about ionic compounds, and we're going to continue to talk about ionic compounds. And so how you know something is ionic, once again, is if there is a metal in the compound. And so if you're looking at your periodic table, if you go over here and you click the metal part, it'll show you everything in here that's a metal, okay? And so all of these are metal that are highlighted, all right? And so we went ahead and showed, yes, it's a metal. Then the question was, is it a transition metal? And the answer was a no. And so the reason being is because our transition metals are these metals right here. And so we did everything but these metals. And we're not going to get to transition metals until Thursday, okay? And so what I'm going to introduce next is polyatomic ions, okay? So right now, you gone ahead and said, is there a metal? Yes. Is there a transitional metal? It's going to be a no. And then you're going to be counting the different elements. And this is the crucial part that you're going to be using today. So before, we did what's called ionic binary. So we did something that only had two elements. So if we look, we did something like potassium chloride or aluminum oxide. Okay, we're going to be doing stuff that has polyatomic ions. And so the only difference is there's three or more elements with a metal in a polyatomic ion. Okay, and so what made this ionic up here, it was a metal and a nonmetal. Aluminum was a metal, oxygen was a nonmetal, and so we did those already. Now we're going to be going ahead and adding, okay, the only thing that's different is it's going to be a polyatomic, and there's going to be a metal to start, and now there's going to be multiple types, and this is how you guys can differentiate. So if I were to have you guys differentiate these four here, well, the question is it going to be two or is it going to be three or more? If it's three or more, the answer then tells you that there's a polyatomic in there. Now, on your flow chart, you guys have all the polyatomics listed. You're not going to have to memorize these. So it's being able to identify if there's a polyatomic ion, okay? And you get the charts, all right? So when we look at the flow chart, we're going to be doing three or more elements. It's going to be a metal and a polyatomic ion. So you're going to name the metal and then name the polyatomic ion. Do not change the ending to "ide" because you just named the polyatomic ion. So I've given you guys a homework assignment, okay, and I'm giving you guys the polyatomic ions. You have phosphate, sulfate, bicarbonate, carbonate, nitrate, acetate, hydroxide, and ammonium, all right? So there's nothing tricky about it. So let's go ahead and if I'm giving you guys a compound name, I want you to get the formula. So you have lithium and you have nitrate. I'll give you a hint. Your polyatomics are going to start with or end with eights and ites. Now, there are a few that you have to memorize, like hydroxide and ammonium. But the most of them, if you look, 8, 8, 8, 8, nitrate, acetate. Okay, so they all end in 8. So if you look down here, you can kind of figure out nitrate. You know that's a polyatomic ion. Sulfate. Okay, if it was a element, it would be sulfide. If it was a element for nitrogen, it would be nitride. So understand nitride is different than nitrate. Okay, so nitrate is NO3. All right, and so once again, if you guys are struggling to find the polyatomics, I've given you guys all of them. So you can kind of see carbonate, chlorate, chlorite. Okay, so most of them end in 8 and 9. So you can notice that's why most of these 8s and ites are boldened. So you guys can see when you're looking at a polyatomic, when you're looking at a name. All right. So it says lithium and nitrate. And so because it says 8, I know this is a polyatomic. All right. Well, so lithium, I got to look at the periodic table. And so if I'm looking at lithium, lithium is number 3 and it's a metal. Okay, and the reason I know it's a metal is because I cover metal. It's going to be highlighted. So I know this is going to be a positive ion, and it's in group 1. And so remember, everything in group 1 has one valence electron. Okay, and because of that, they're going to lose and they become positive. Okay, so lithium is going to be Li plus 1. Let me see if I can. Oh, what did I do? Okay, so lithium is going to be lithium, and I'm just going to draw it. It's going to be plus 1. And then you have nitrate. So I look up here, you can see nitrate, it's NO3 minus 1. So it's NO. I know there's a way. Where's it at? Okay. NO3. All right. I'm going to go ahead and get rid of that now that I know how to. So if I go to lithium here, I'm going to go ahead and put the charge. It was positive. Positive 1. And nitrogen, or nitrate, not nitrogen, is going to be negative 1. Now, just like we did for the ionic bonding, okay, all we do is we switch the charge. So this positive 1 is going to come outside NO3, and this negative 1 is going to come right down by Li. And so what it's saying is it's going to be Li1 NO3 1. And so how we write this, it's going to equal Li, and what I like, and I make it simple, put all your polyatomics right now in parentheses, and now there's only one NO3 due to the charge being 1, okay? But at the same sense, it just helps you identify that you've found a polyatomic. So it's going to be LiNO3. Now, if you didn't put the parentheses, that's fine. Okay, so let's go ahead and look at sodium and sulfate. So once again, sulfate has an 8, so I know that it's going to be a polyatomic. So if you look up here, the sulfate ion is SO4 minus 2, but I have to find sodium, and I got to see if sodium is a metal. So if I look on the periodic table, sodium is also in group 1, and if I highlight my metals, it falls under the highlighted metals. Okay, and so sodium is also going to be positive 1. So I have Na, and it is also plus 1. And then my sulfate is SO4, and it's a negative 2. And you guys can see they're given to you. So this isn't something that you're going to have to figure out on your own. Okay, and you can always look on your flow chart. I give it to you. Okay, so sulfate is here. All right. All of them are up here, so if you ever need to, nitrate's here. And so if you're looking at this flow chart, if you just see a minus or a plus with no number, it's a 1 next to it. So just understand that. Okay, I've given you the ones up here. So once again, I'm dropping my charge. So my plus 1 is going to drop down to SO4, and my negative 1 is going to drop down to negative 2. And so what this becomes is, because my 2 drops down to Na, it's going to be Na2. And then once again, I'm going to go ahead and put SO4 in parentheses. You don't have to, but this also does help me identify that you've identified a polyatomic ion. Okay, and once again, there's only one SO4 because this positive 1 dropped down. Okay, so if you didn't put the the parentheses, you didn't have to. So if you did, it's fine. So once again, let's go ahead and look at potassium phosphate. So once again, phosphate has an 8 next to it. All right. And so I have to see if potassium is a metal. And so if I look, potassium is also in group 1. Okay. And it falls under the metals. So because it's in group 1, it's positive 1. Okay. So if I'm going to go over here, I'm going to go ahead and type in potassium. It is also positive 1. And then I have phosphate, which is PO4 minus 3. So it's going to be PO4, and then it's a -3. And now the charges are going to drop. So this negative or this positive one's going to drop down here. This -3 is going to drop down here. Okay, so my new polyatomic becomes K, and now it's going to be K3 because that 3 drops down. So it's going to be K3, and then it's going to be PO4, and there's only one PO4 because the positive one drops down. Okay, so once again, I'm going to put a parentheses around my polyatomic ions. Ooh, PO4. All right, and so these are going to be my polyatomic. Now, understand, I'm going to just give you guys an example of anything that might drop outside these parentheses. So I'm going to give you something in group 2 as opposed to potassium. So just so you can see that you would have something outside the parentheses. So let's just say we did potassium. Let's just use calcium. And calcium, so let's do calcium phosphate. And I'm just making this up so you guys can see. So I'm going to go ahead and just add this in here. Calcium phosphate. All right, and so this is just something I'm adding in here for you guys. And so this is going to be Ca, and it's in group 2, so it's a +2. And then you also have phosphate, and I'm going to use it again. It's PO4, and it's also a -3. So it's going to be PO4, -3. And so now this is going to be an example where you have a number outside the parentheses. So this 2 drops, and then this 3 drops. So it's going to be Ca3. Ca3 is that 3 drop from the phosphate. And now this is where you're going to need parentheses. All right, and so it's going to be PO4, closing the parentheses. Now I have to put outside the parentheses the 2. All right, and so I don't ever want to change the actual polyatomic ion. Don't think PO4 becomes PO2 because of this positive. This positive is only going to drop down and tell me how many PO4s I have. And so you got to think it's going to be multiplying inside those parentheses. Okay, so if you ever get one that you have to use numbers outside, all right, it's usually when you have a positive charge that's going to be greater than 1, like calcium, which is +2. Okay, so for the remainder of these, you guys are going to go ahead and give me the chemical formula. And so I've given you guys all of the polyatomic ions. So every single one of these has a polyatomic. I'm not trying to trick you in any way. Okay. Next week, I'm going to start mixing it up, and you guys are going to have to be able to identify the difference of a compound that does have a polyatomic and one that doesn't, and how the naming is different. Okay, so follow these rules. Go ahead and finish this practice 1 through 10, as well as the 3 that we haven't done. And then also what you're going to have to do is you guys are going to have to give me the chemical name if I give you guys the formula. And this is very, very simple. 1, is it polyatomic with a metal? Okay, and the answer is it 3 or more elements bonded together? Well, if you look, every single one of these has 3 or more elements. Some of them even have 4. Okay, and so that is what follows the rule here. Okay, so yes, there's a metal. Okay, so we'll go ahead and do barium carbonate. All right, and the reason I know it's carbonate is it's CO3. Now, it's BaCO3, all right? And so the charges have already been dropped. You don't have to do anything. And the reason being, and I'm just going to go ahead and show you why, barium is in group 2. So we can see barium right here. It's in group 2. It's a metal. So it's going to be Ba+2, and it's already been done, but I'm just going to show you so you can see how this has already been formed. And then the carbonate is CO3, and it's -2. And so again, I take my charges and I drop them. Okay, so just like we did up here. And so carbonate is -2 up here. So I just went ahead and switched them, all right? And so when I drop them, some of you are like, well, Mr. Sasky, it should be Ba2 CO3 2, all right? And so I'm going to show you why it's not that. So you have Ba, and then you have, it should say 2, and then it should be CO3. And again, you should have it 2. But the problem is if you have subscripts, now ignore inside the parentheses. This is why it's crucial for you guys to put parentheses so you know what never to change. Okay, so if you guys notice, the 2 and the 2 that I dropped, they're the same, so they cancel out. Okay, they both can be reduced by 2, which is why we see a 1 and a 1 here. Okay, and so we don't put 1s. So once again, we have a metal, because barium is a metal, and we have carbonate. And if you want to put those parentheses, be my guest, okay, if that helps you. So we have barium carbonate, all right? And so what I'm going to put is name the metal. You just name it barium. And then CO3 is carbonate. So I just name what it shows me, all right? So if I look here, it's easy to distinguish what the polyatomic because it's in parentheses. So you can already look C2H3O2. Well, let's go ahead and look up here. C2H3O2, it's acetate. So I already know it's going to be something acetate. All right. And so I have to look to see what that metal is. And so strontium is a metal, and if you don't believe me, cover the metals and strontium's under there. So it's going to be strontium acetate. So I just write it out. Name the metal strontium, and then I name the polyatomic. All right. And so you're going to do this for the remaining 8 of these. All right. And so this is all you're going to be doing today and tomorrow. I'm going to be posting an answer key tomorrow for you guys to check your answers. So please, if I don't or I forget to post it, please send me a quick email and I'll post that on there.